Hey everybody, it's Mr. Morse. We're going to talk a little bit about types of chemical reactions. So we know there are 5 types of chemical reactions: synthesis, decomposition, combustion, single replacement, and double replacement. And just from the reactants, I can actually tell which type of reaction we have. So in a synthesis reaction, we're going to have 2 pretty simple elements that are going to react together. And they're going to produce one compound as the product. So we're going to take those 2 elements and hook them together and make one compound as the product. And maybe an example of that would be something like taking some copper, reacting it with some oxygen from the air, which is what happens on the Statue of Liberty, which is why she's green instead of that penny kind of brownish coppered color. So I have 2 simple elements, copper and oxygen. They're going to react to produce one compound of copper oxide. And in this case, I have my compound, and I only have one compound on the product side. The next type of chemical reaction we have is decomposition. So in decomposition, we actually have one reactant, which is a compound, breaks apart to produce 2 simpler products. Sometimes those are just 2 elements. Sometimes it might be a simpler compound and an element too. So in this case, we could have, for our decomposition reaction, maybe we have something like calcium, let's say fluoride, and that breaks apart into the 2 elements that make it up, which would be calcium and fluorine. The one thing I have to check is, remember, our diatomic elements, those 7 elements that are so reactive they always come hooked in pairs. Again, we use the word Hofbrinkel to try to remember those 7, which are hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. In this case, when I check, calcium is not part of the Hofbrinkels. However, fluorine is. He is diatomic, so I got to make sure I put a little 2 right there. And by doing that, this equation actually becomes balanced as well. So decomposition, we're breaking apart. We now go to combustion. Combustion is burning. And what we have is a hydrocarbon, which is a carbon-hydrogen compound that reacts with oxygen. And we always produce carbon dioxide and water. So in this case, all hydrocarbons are organic compounds. Could be something like propane in your gas grill out back. Could be the parts that make up a log, which are also mainly a hydrocarbon. When we burn it, it reacts with oxygen from the air. We get carbon dioxide and water, as well as a couple other products, but we're going to skip those for now. So in this case, any hydrocarbon might be something like C3H8, which would be the propane from your grill in the backyard, reacting with oxygen gas from the air, which is another diatomic element. He's one of the Hofbrinkels, so I got to have 2 of them. And we're always going to make carbon dioxide and water. Doesn't matter if my hydrocarbon is C1000, H a billion. I'm still going to react with oxygen from the air, and I'm still always going to produce carbon dioxide and water. So combustion, once we know it, is probably the easiest to recognize, the easiest to predict the products of, however, is the biggest pain sometimes to balance. So next, in our single replacement reaction, we usually have a single element, which 99.9% of the time is going to be a metal, and a compound, which is going to be ionic, containing a metal and a negative ion. Could be a polyatomic ion, could be a single element. And in this case, our metal is going to be the positive ion, which is also known as a cation. And our negative ion, whether it's a single element or a polyatomic ion, is known as an anion. So for this guy, maybe we have something like sodium, which is a metal, which is our single element, reacting with zinc sulfate. So in this case, zinc is our positive cation, sulfate is our negative anion. And these guys will produce sodium sulfate and zinc by itself, which, depending on what the problem is, just based on those reactants, you might have to tell me those products, or I might give you both reactants and the products, and you have to recognize that this is a single replacement reaction. And last but not least, we have double replacement, which is two ionic compounds that are both aqueous, which means they're solutions that we're mixing together, and they react to produce two ionic compounds, and one has to be a solid precipitate in order for this reaction to actually happen. So an example of this might be, see if we can get our pen going here, something like sodium phosphate, which is aqueous, reacting with some lead nitrate, which is also aqueous. And right there is enough to know that's double replacement. And then what we're going to get is some sodium nitrate, which is also aqueous. And I'm running out of room. And then we're also going to get some lead phosphate, which is going to be a solid. So the biggest thing is that we have two compounds. They're both ionic. They're both aqueous. The two metals, the sodium and the lead, are going to change places to make the products if they so happen, which we'll get to here in a little bit. But we know just by the fact that we have two ionic compounds on the reactant side that we definitely have a double replacement reaction. So again, just as a little review here at the end, synthesis, two simple elements produce one compound at the end. They hook together. Decomposition, you start with one reactant, which is a compound that breaks apart into two simpler products, usually two basic elements, maybe one simpler compound and an element as well. Combustion, which is burning. Hydrocarbon, reacting with oxygen. You're always going to make carbon dioxide and water. Single replacement, you have a single element, which is usually a metal, trying to react with an ionic compound containing a metal and taking its place. We know that that happens as long as the metal by itself is more active or reactive than the metal in the compound. And finally, double replacement we can recognize because we have two ionic compounds, which are both aqueous. They're going to react, and they're going to produce two new ionic compounds, which if one is a solid, called a precipitate, we know the reaction occurs.